Hey, today we're going to learn about Python lists, how to combine them, and some performance tips that you probably haven't heard anywhere. So I am here in the Python REPL, and a list in Python is just a collection of things, right? Like x equals 1, 2, 3, right? This is x is a list of strings, right? And we can do y. We can do spell correctly helps. It actually doesn't matter. But now we have two lists, right? So the easiest way, the default way, the way that you should lean on most of the time to combine two lists is just using plus, right? So x plus y gives you this, and I can assign it to z. I can say z equals x plus y, and then z is that as well, right? So that is the default way to combine lists. But there's some edge cases where this might not be what you want to do. So let's go through some of them. What if you have a really large list? Like what if you have a long list that is like much bigger? There's my x, but there is my long. It goes on for a long time. And I can make a short list just directly equal to y, right? So if I want to combine those lists, I can obviously do it the same way, like that. But that is going to make a new list with all those elements in it, and there is a process by which those pointers get moved over, and that can have some overhead. For instance, let's test it out. If we do import, we're going to import the timeIt package and clear the screen. I'm going to copy this over to save some typing. So I'm going to make this string setup, and it contains the Python code that I just showed you. So we're making a long list that's 1, 2, 3, 4 repeated 1,000 times, and then a short list is just 4, 5, 6, right? And then we can test this by using timeIt. timeIt takes a bunch of stuff. The first thing is the thing that it's going to time. So we're just going to time long plus short. It's going to take that string and it's going to evaluate it. But first it's going to do a setup. For setup, we're going to give it the setup string, and then we're going to try this 1,000,000 times, which is that many. Let's see what happens. So timeIt gives us a nice way to just check the performance of running something. And I hope that I counted this out right. Yes. So it can do this concatenation, this addition. 1,000,000 times takes 7 seconds. So there is another way to combine lists, which is using the extend method, and it does something slightly different. Instead of adding the elements together into a new list, it's going to add them onto the end of the existing list. So we can do that. And then if we print out long, we can see right around where my head is the start of the second list. Let's clear that. So what I'd like to try is using this and see how long that takes. So before we were at 7 seconds, and then if we change this here, what we're going to perform using extend, what is our performance? Look at that. So we went from 7 seconds to 0.1 of a second, so at least 10 times faster, maybe 50 times faster. I don't know. There's some randomness just in running these. We'll probably get a different number if we run it again. Pretty close. But you can see that's way faster. And the reason is that it doesn't have to create a whole new list with all those long elements in it. It starts with the long already. Obviously, that is different. Like you're modifying the existing list. So it has some different, you have to use that code differently. But it can be a great way to speed up your Python code if you need to combine elements in a list, right? So that was like 3,000 elements. We took our list of 3, multiplied it by times 1,000. But what happens if the elements in the list are large? So it's not that the list has a lot in it, but the things in the list are very big. Like the first element is, I don't know, the complete works of Shakespeare and a giant string, and the second is a dictionary, and the third is, all of Wikipedia. Like, how does that work? So let's test that out. So one way we might do that is we'll make a new list, right? And we'll go 1, and then we'll just multiply the length of that element out, right? So we can go 2 times 1,000, like that, right? And if we look at that, we can see now we have much longer elements in the list, right? And we could do the same with y, and then we could add them with, z equals x plus y. Or we could use the extend, which is going to be faster. So let's use time it again. I'm just going to copy this over. So here's my setup code. So it's the list is only going to have 3 elements, but they're going to be very large, and same with y, right? And then we're going to use our time it. We can just scroll up and get our previous time it, right? But now instead of x and y, instead of long and short, let's just do x plus y. So now, before we had like 7 seconds, but now with a much shorter list but with much bigger elements, you can see is very fast. We're 0.15 of a second. And we can try this also with extend. So if we do x, extend y, then it's pretty close. Let's try that again. There's extend, and there is x plus y. So x plus y seems maybe a bit faster. It's like it's neck and neck. But the important thing is that there's no advantage here to using extend, right? You might as well make a new list with these elements in it, which tells you something interesting about what's happening under the covers, right? It's not actually moving the values inside the list, but just pointers to them. So what matters is not how big the values of the list are, but how many there is. And in this case, we have very big values, but there's not very many of them. So we might as well just use the plus to do our concatenation, x plus y. Another thing you might have heard of is the chain method from itertools. I don't know if that's how you pronounce that, but it's iterators. It's tools for iterators, and we can import chain from that. And with that, we can do something like instead of x plus y, we can make a new list that is a chain, and the chain is made up of x and y, like that, right? And we can print out z and see our results. And if we don't wrap it in a list, let's just make the chain like that. We see that we have a itertools.chain returned. The iterators are lazy, I believe, so it's just producing the elements as it goes. So if I print it out, we don't actually get the results. We get that wrapping object. So wrapping in a list, we have to create a new list, but we're forcing it to iterate through those elements. So let's test out that. So we have our setup where we're going to import our elements. And then we're just going to test the x plus y. Oh, indent error. This is always fun. I always forget. What? Let's try this again. We copy in, but I've copied in the space here, so I'm going to delete it. Just option click, alt click to move around, by the way. And you can see 0.29 there. We have a much, excuse me, we have a much smaller list here. I've only multiplied it out times 10, and you can see it takes 0.29 seconds while recording this video at the same time. So performance is probably, these numbers are not ideal, but they're relative to each other, so we can use them as a measurement. So now I want to use this other element. So we want to do list, chain, and we have x, y. So let's try that. See what happens there. It says I didn't close something. We're going to need one more bracket. Well, thank you, Python REPL. And now you can see that is taking 1.5 seconds. So the chain method is not faster. If you're just combining two lists and you need a list back, no reason to use that I can think of. But it is great in some other circumstances. It works on many things. It can work on dictionaries, anything that is iterable. One thing it's really great for is if you have nested lists. So if I have a nested list like this, right, it is a list that contains a list and other lists of varying lengths. So it's something like that. And I want to turn that into a list. So it's like combining lists. You need to get all the lists that are inside of this list and combine them. So it's like combining a list of lists or flattening. Itertools is really nice for this. You can take a list of basically calling chain from iterable, if I've spelled that right, 50-50 on that. Look at that. So the chain.from iterable will flatten that out lazily, and we wrap it back into a list, and we get our nice results. Of course, we just saw that using chain can be slow, so maybe there's a faster way to do it, right? Like it would be possible. Like one thing you could imagine doing is something like this. Instead of using that chain from iterable, knowing that extend is faster to add items to lists, we could do things this way. We could take our L, which you remember looks like that. We could go in a for loop through it, and each time we hit a new element, we could extend it onto the list, right? And that, let's try this. No, it's not. So that would be another way to flatten out this list. And so let's see which one's better. So here is my setup where I'm building my L list. Let's see. So if we run the chain from iterable, it takes, somewhere around 4 seconds. Now we need a way to run our own method. Time it, it uses these strings for a val, or you can pass in a lambda. Passing in a lambda might be a preferable way to do things, but if I put my loop that I used from before into this string and I call it run, then I can go up to my previous method here, right? And now instead of giving it this string, I can just give it the string I wrote ahead of time called run. And what we're expecting here is it to be either faster or slower than around 4 seconds. Really, my expectations are maybe it should be faster because we're using extend, which we already saw is faster than using chains. And drum roll, please. What do we get? Oh, look at that. It's at least, 1.5 seconds longer. It's like 5.5 seconds. And I guess up here we got 3.7, so almost 2 seconds faster. So the lesson to learn here is no reason to write this ugly looping code yourself when you can just use chain.from iterable. Chains are slower than concatenating when you just have 2 lists, but when you have a bunch of lists, it's actually a really good tool to use. What this all shows is chain.from iterable is faster when you're flattening lists. That's what you want to use. And also it's just easier to understand. But overall, what we've seen is in almost all cases, you just want to use plus. If you're combining two lists, you want to get a new list, you use plus. If you have a really big list in terms of number of elements, you might want to consider extend. It won't make a new list, you just add on to the existing list, but it can be a lot faster because you don't need to copy over those elements. But if that really big list is big because of the size of elements, then that doesn't matter. You might as well just use plus. In other words, the big summary is in all cases, you probably just want to use the plus operator to concatenate 2 lists, but there are some special cases where you can do other things. And also, it's just fun to use time it to test these things out. Yeah, hopefully you found that interesting. And the last thing to cover is Earthly, right? So I work for Earthly, so you can check that out at earthly.dev. Earthly is an open source build tool, great for building projects in Python, it's sort of like Docker for builds. It makes it easy to do CI, makes it easy to test your CI locally. Yeah, it is great. And maybe I should write that out. So it's great because it is a local CI. It's great because it is Docker for builds. And what's another one? It works with your existing CI and locally, which is awesome, right? So check out earthly.dev. And if there's other Python tips that you want to hear, if there's things you want me to walk through, let me know, because I'll probably be making some more of these videos. Just leave some comments below, I guess, at what you'd like me to cover or anything you think I got wrong. All right, thank you very much. Take care.